Okay, in this video I am going to do problems 9 and 10 from homework number 1, and I will start with 9. It says to simplify the following Boolean functions using the rules of logic. So I'll start with part A here, f of p and q. Let's write this down. F of p and q is equal to not p and q or p. And I'm going to just distribute the not p. I'm going to do distributive law of and over or, and I'll have not p and q. And that's going to be ORed, and I better put parentheses around it, with not p and p. But now we see the simplification because not p and p is a contradiction. So we have an OR with a 0. And anytime we have anything ORed with a 0, it's itself. Okay, because if itself is true, then the OR becomes true, and if it's false, the whole thing becomes false. So there's a simplification. It's just not P and Q. So that's part A. For part B, I'm going to write G of P and Q is equal to not Q or P. And I'm just going to apply De Morgan's rule to this and take the minus sign on the inside, and it flips the sign on the Q, flips the OR into an and turns the P into a not P. And I guess that's about all you can do with this one. Q and not P. Hey, it's just the same as the previous one, it turns out. These two parts A and B are equivalent, it turns out. And I guess you could say that this is simplified because it has fewer symbols in it, I guess. In any case, that's what I was looking for there. Finally, for part C, H of P and Q is P or Q. That thing ANDed with P or not Q. And what I'm going to do here is I'm going to factor out a P or. I see the common term there, and there's an and. I'm mixing the ands and the ors, so I need the parentheses, number 1, and I can do the distributive law. And so I'm going to have P or, and now I'm going to do the Q, Q, and not Q. And again, I get a contradiction here, P or a 0. And now in the same way as in part A, anything ORed with a 0 is itself. So there's the simplification of part C. It simplifies down to just P. Okay? So number 10 we'll do here on the next page. Let's see. We're supposed to use the rules of logic, start with De Morgan's, then rearrange terms so you can distributive law, and finally apply negation and bound rules. Okay, let's just write this thing down. Not Q or R or P or R and Q. Now you see here, I'm tempted to say, oh, I got a bunch of ORs in a row, I can take out the parentheses. But no, this thing here is negated. And so this OR is not on the same footings as those two ORs. So I'm going to go ahead and apply De Morgan's law first. And I'm going to apply De Morgan's law right here and turn this into a Q and not R. And that thing is ORed with P and ORed with R and Q. Now I'm going to see that I have a Q and in two places here, so I can factor that out. I guess what I'll do is first I'll write this as Q and not R. And you also notice that I can rearrange the order in three things that are ORed together. In other words, A or B or C is equal to A or C or B in any order. Okay? And so I'm going to take this one next. And I can also rearrange the R and the Q here in the AND statement. So I'm going to go R or, and now I'm going to write Q and R, and finally OR with the P at the end. Okay? And now you can see very clearly that I can factor out the Q and. and I'll get a not R or R. And that whole thing is going to be ORed with P, and so I better put a parenthesis around it. Finally, R or R is a tautology. It's always true, so I have Q and 1. That thing ORed with P. Anything ANDed with 1 is itself. I think that's called either bound or negation rule. So Q and 1 is just a Q. In other words, if Q is true, I have 1 and 1, and the whole thing's true, and that's equal to Q. And if Q is false, I have 0 and 1, which is false, which also equals Q. So anything ANDed with 1 is itself. And finally, Q or P. And so now we have the simplification of this big, long statement into the simple Q or P. Okay? Hope that helps. And that completes my videos for homework 1.